So in quadrant 1, and we could just say quad 1, quad 2, quad 3, quad 4, but in quad 1, we want to draw the rotation angle theta in standard position and complete the table. And we want to repeat this for steps 2, 3, and 4 as well. So if I start here and I rotate up to this portion here where I'm at this point, in quadrant 1, then I want to say what my sine is going to be. So the first one's done for us. The sine of theta is equal to y divided by r, and both of those are going to be positive in this case, which means when I divide a positive by a positive, I get a positive. And cosine theta, remember, is x divided by r, in which case these are both positive again, and a positive divided positive gives me a positive. And with tan theta, this is equal to y over x, which again, in quadrant 1, is a positive divided by a positive, which results in a positive. Now, when we move over to quadrant 2, and we rotate my terminal arm into quadrant 2, for the sine theta, again, this is y divided by r. And this time, well, actually, sine is going to be positive here because y is positive, right, going up. And that results in a positive r as well. And that results in a positive overall ratio. However, with my cosine, now x is negative where my y is positive. So we would have a x over r, but x here is negative divided by positive, resulting in a negative ratio. Same with our tan ratio here, y divided by x. We have a positive divided by a negative, resulting in an overall negative ratio. Quadrant 3, we're still completing these ratios, x over r and y over x. But now, notice how I have a negative x value and a negative y value. So negative x and a negative y. And your value of r, remember, if you're using your Pythagorean theorem, is always going to be positive. So that's one thing that you can remember. But in this case, I have a negative divided by a positive, resulting in a negative. My x is negative again, divided by a positive, resulting in a negative. But my tan ratio in quadrant 3 is going to be positive because I have a negative divided by a negative, which results in a positive. Now, I should have drawn my rotation angle as well. And I'll draw my last rotation angle in quadrant 4, where I have positive x and negative y. So I have y divided by r, x divided by r, and y divided by x. So in this fourth quadrant, my value of y is negative, and my value of r is positive, resulting in a negative value. My cosine ratio here, however, is going to be a positive x divided by positive r, resulting in a positive. And my tan ratio here is going to be a negative y divided by a positive x, resulting in a negative trig ratio. So sine ratios have positive values in quadrants. So my sine ratio was positive here in quadrant 1, and it was also positive in quadrant 2. Cosine ratios have positive values in quadrant 1, but also in quadrant 4. Tan ratios have positive values in quadrant 1, but also in quadrant 3. And then we have our sine ratios again that have negative values in quadrants 3 and 4. And our cosine ratios have negative values in quadrants 2 and 3. And our tan ratios have negative values in quadrants 2 and 4. Now, these ratios and their positive values, they can be memorized. So we can memorize them again using another mnemonic using another mnemonic or acronym, add sugar to coffee, or the CAST rule. So the CAST rule goes like this. So you start down here, C-A-S-T. So C-A-S-T, where the C stands for cosine ratio positive, A stands for all ratios positive, S stands for sine ratios positive, and T stands for tan ratio positive. The other mnemonic, add sugar to coffee, does the same thing, all sine, tan, cosine. So we could, in using our CAST rule or our add sugar to coffee mnemonic, we can determine without using technology whether the trig ratios are positive or negative. So the sine of 340, and the way we would do that is we would go something like this, make a little Cartesian plane and think about where sine 340 will be. Well, 360 degrees is here, which means my angle would terminate somewhere here, which means if I'm looking for the sine ratio in this quadrant, only the cosine ratio is positive, so my sine ratio would be negative here. All right, and so we would continue like this. So 180 degrees is here, 270 is here, which means 227 is in this this quadrant, which means that that's quadrant 3, and my tan ratio is positive in quadrant 3, so that's going to be positive. Sine 80, actually let's do a cosine, we'll jump down to D here. So my cosine ratio at 235 is again going to be in this quadrant, and only tan ratio is positive there, so that means this is a negative ratio. All right, so last, let's look at the trig ratios of an angle in terms of the reference angle. So trig ratios for any angle are either the trig ratios of the reference angle or the negative of the trig ratios of the reference angle. Now, let's see what this means. Now, when we're trying to determine what the trig ratios are for any trig ratios of a reference angle, we want to determine the sign of the ratio, so either positive or negative, and then we want to determine the measure of the reference angle. And then we want to combine both 1 and 2. So the sign and then the measure of the reference angle. So for example, to write cosine 260 degrees as the cosine of an acute angle, using this procedure, we would first think about cosine 260, and we want to think about whether or not this is going to be positive or negative. So 260 degrees would be right here, and or around, it's actually going to be closer to here, sorry, because this is 270, it's going to be 10 degrees less of that point, but it's going to fall in this quadrant. So we know that that's going to be negative because only tan ratios are positive in this quadrant. And then we would want to find out what the measure of the reference angle is. So we would go 260 degrees minus 180 degrees, and that would give us 80 degrees. All right, so it's negative. We have a reference angle, so I'm going to say reference angle of 80 degrees, and we would then go cosine 260 degrees is equal to negative cosine 80. All right, so negative cosine 80. And that's expressing it as an acute angle. So if we were typing it in our calculators, cosine 260 is equal to negative cosine 80. Let's look at this example where we're rewriting these as a trig function of an acute angle. So first of all, let's find out where sine 140 is. So 140 is going to be here abouts, and that's going to be positive. And my reference angle is equal to my 180 degrees, subtract 140 degrees, that is equal to 40 degrees. So sine of 140 is as an acute angle is equal to sine 40 degrees. And I'm just going to do cosine 165. So I'll take the same approach. Cosine 165 is over here, and a cosine ratio is negative here. So if that's negative, then what we want to do is now find my reference angle. So that's that one there. So the reference angle is equal to 180 in this case minus 165, and that's equal to 15 degrees. So then that's, since it's negative, then that's going to be negative cosine 15. Oh, and degrees. Last, take a look at these patterns, and I'll talk about these in class. But yeah, just make sure you take a look at those as in preparation for Monday's class.